All right, so now we're recording, and I'll share the screen. One thing I do want to mention about that, so I sent the video. You should have gotten the video if you want to look at it. You're not required to look at the video. I mean, it's optional. I know. So that's what's wrong. So you don't have to look at the video. I will say one thing about the video. Once I start recording, I don't turn it off because I noticed that if I try to turn off the camera during a break and then turn it back on, it doesn't really work. So we are recording even during the break. Okay, so sorry about that. There's no way I can get around that. So if you look at the recording, there's going to be 10 minutes of dead time around the break. But if I record straight through, I know I don't have any problems. If I try to turn off during a break and then turn it back on, I have problems. Okay, so just fast forward the 10 minutes of break or whatever the case may be. All right, so I was actually done with 1.1, so I'm going to do 1.2 and maybe sneak in some of 1.3. In fact, I'm hoping to do 1.3 also. Okay, and then tomorrow at the end of class, you'll have your first quiz. Okay, and it's a reminder of how a quiz works. So I'll give you 1 or 2 or 3 questions at the end of class, and then I'll put you into breakout rooms. Okay, and then within your breakout room, you put down your name and everybody else in your breakout room's name, and hopefully everybody writes the same thing. Okay, you submit it, so just take out your cell phone and take a picture, click, click, click of all the problems. Okay, I will probably decide to only look at one of your 3 or 4 people's quizzes, and I'll grade that, and everybody's going to get the same grade. Now I'm going to glance at all of them. Okay, so within your breakout group, if I look at all 4 quizzes, and hey, this looks like it's all written by the same person, right? Okay, you can't do that, obviously. Okay, so everybody has to have their own writing. Okay, so I can look at it and say, okay, your writing is different than this person's writing, and so on. So I do kind of want to get to know what your writing is like too, to prepare myself for exams and so forth. But I'm probably only going to look very carefully at one of them, and everybody's going to get the same grade. So I'll grade one person in the breakout group of 3 or 4, and whatever that person gets, everybody will get the same grade. So your object, if you're the straight A student, you don't want to just hide it to yourself and then leave, because you have to get everybody else in your group to write the same thing also. And again, you can't just copy this or say oh, here, take the same thing, but it's somebody else's writing. Obviously, I can look at it and tell, hey, all 4 people have the same writing. What's going on here, right? So you want to get everybody in your group to write the same thing, and hopefully it's all correct, obviously. That way you can be assured that whoever I pick from your group, you're going to be okay, right? So that's what I want to say about that. How much time do you get for the quiz? Usually 20, 25 minutes. Okay. So, and then when it gets to the end of class, which is what, 1 o'clock, then just take a picture on your cell phone. So, like when we met on campus, right? Then I would say, okay, quizzes are due when class is over at 1. So same thing. When class is over, that's when the quiz due. Just take a picture on your cell phone, submit it, put your name, put everybody else's name, and then I'll grade only one person in that group. Okay, go ahead and put more questions in the chat if you want, but I can't read that now. I do want to go ahead with new material. Okay, so I'm going to do 1.2, maybe some of 1.3. Here it is. Again, how do I lecture? I lecture by just doing a lot of these problems. Okay, so I'll help you out by doing a bunch of these problems. Okay, so 1.2, we are doing absolute value. Okay, and again, in case you say to yourself, I don't want to buy the book, you can do that. I'll just show you all the problems. Okay, so 1.2 is on absolute value. I showed you all the problems from 1.1 yesterday. If you're not sure about that, you can ask me or catch the video. Okay, 1.2 is mostly on absolute value, 1 to 59 odd. We're on page 9. Okay, so I'll try to show it to you. And don't worry about the speed. If you say I'm going too fast, don't forget this is all in the video, and you can pause, fast forward, rewind as much as you want. And some more, whoops, some more over here, and here, and here. Okay, and we just have to go up to 59. Okay, so that's it for that. And while I'm at it, I might as well show you 1.3, which is in solving equations. 1.3 was, let's see, 1 to 57. Every other odd, it's too much to do all the odds. Every other odd means 1, 5, 9, 13. So that means you do 1, but skip 3, do 5, but skip 7, and so on. Another way to think of it is start with 1 and keep adding 4. Okay, so 1 plus 4 is 5, plus 4 is 9, plus 4 is 13, and so on. Okay. Again, I do hear some background noise, so can everybody please mute yourself? Okay, yeah, that's one thing I quote unquote don't like. It's something that you should do. So please mute yourselves, and that would help me out a lot. Okay, so 1.3, every other odd. By the way, EOO right there means every other odd. Page 17. Okay, so you do 1, 5, 9, 13, right? Okay, and then on the next page, page 18. I don't want to hold up the book too much because it gets kind of heavy, as you can tell. And some more. And more. Whoops. More over there. Okay. More there. I'm not sure I get to do all these, but I'll show it to you anyway. That should be it. Okay. Then I'll do this for the whole semester. So you can kind of survive without even getting a book. Okay. All right. So I'm going to start 1.2. 1 to 59 odd. I'll do a bunch of them. A lot of the beginning ones are so easy, I'm not even going to write anything. I'll just say it. Okay. So even though I'm doing 1.2, I'm writing 1.2 on my paper. But the first ones are so easy, I'm just going to talk about it. Okay. So we know what absolute value does, right? It changes negatives to positives, but leaves positives alone. So number 1, absolute value of 3, leave it alone, 3. Question 3, absolute value of negative 6, 6. So that's pretty easy, right? Okay, so I don't need to write anything there. I will write some stuff for these, okay? So how about I'll show you number 9. Okay, so I'll write it for you. Okay, question 9, absolute value of negative 6 plus 2. Oops, sorry, it was minus absolute value of 4. Okay, absolute value of negative 6 plus 2 minus absolute value of 4. Sorry, that's a minus sign. Okay, negative 6 plus 2, negative 4 minus absolute value of 4. Okay, absolute value of negative 4, 4. Absolute value of 4, still 4. So 4 minus 4 is 0. So that's all there is to it. Right? Okay, 15, absolute value of 7 times negative 8 minus absolute value of 7 times absolute value of negative 8. You write it like that. Okay, 7 times a negative 8 is a negative 56 minus absolute value of 7 is 7. Absolute value of negative 8 is 8. Absolute value of negative 56 is 56. 7 times 8 is also 56. So once again, the answer is 0. So no big deal there. So when you have the absolute value, just change negatives to positives, leave positives alone. Okay, so hopefully these are fairly easy right now. Okay, 17 through 23, they give you A, B, and C. So just plug in A, B, and C, and then do the same thing, right? So I'll show you something like that. So it says A is negative 2, B is 3, C is negative 4. Okay, so I'll plug those in. How about I'll show you 21. Again, these are right off the homework. Right? So even though this is the homework, I end up doing quite a bit of them anyway. Okay, 21 says absolute value of a plus b squared minus absolute value of b plus c squared, like that. Okay, so I just plug in. They tell me a is -2, so -2 goes here. B is 3, so 3 goes here and also here. And C is -4, so I put -4 right there, okay? So after I plug in, it's -2 plus 3, absolute value squared, minus 3 minus 4, 3 minus 4 absolute value squared. And let's see what's going to happen. They sure seem to like the number 0 quite a bit. Okay, -2 plus 3 is 1. Absolute value of 1 squared minus 3 minus 4 is -1. -1 squared. Absolute value of 1 is 1. Squared, you get 1. That's also 1. 1 squared is 1. So once again, the answer is 0. We're getting too many answers where the answer is 0, but that's the way it is. Okay, but I'm sure after a while the answer isn't going to be 0. Okay. All right, now a little bit harder. So 17, 19, 21, and 23 are like that. Just plug in. Okay, rewrite each expression without using absolute value notation. Okay, so what does that mean? So I'll do some of these for you. Let's look at 25. Square root of 2 minus 1 minus 1. Okay, square root of 2, I know it's bigger than 1. It's like 1.4 or something like that. I'm going to get your calculator out. Square root of 2, so 2 square root button, about 1.4. Okay. Now, don't write 1.4 here. Okay. The whole idea is that the stuff inside the bars is positive. It's about 1.4, 1.41421, blah, 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 minus 1 is a positive quantity. Therefore, the absolute value is going to be the same thing, which means I just dropped the bars. This is the same as this, in other words. Okay, now I just subtract another one. So that's going to be radical 2 minus 2. So that's the way you write the answer. Don't change it to a decimal. Okay, this is considered the exact value of the answer, square root of 2 minus 2. And just leave it like that. Okay. 27. It says, give the absolute value of x minus 3, and you're given that x is greater than or equal to 3. Absolute value of x minus 3, number 27, given that x is greater than or equal to 3. Now, if I plug in 3, this is 0, right? If I plug in any number bigger than 3, this quantity is positive. Do you agree? So if the answer is going to be either 0 or positive, I can just drop the bars. In other words, this is never going to be a negative quantity. X minus 3. Even though I don't know the value of x, I do know it's greater than or equal to 3. So I plug in any number greater than or equal to 3, it's not going to be negative. Okay? So I can drop the bars, it would just give me x minus 3, like that. Okay. '29, I'll just talk about it, but I won't write anything. Absolute value of t squared plus 1. What do we know about the sign of t squared plus 1? That's always going to be positive, right? Think of it. If I plug in a negative number, right? If you square it, it's positive. If you plug in a positive, it's positive. You plug in 0, it's 0. But then when you add 1, it's definitely positive. So quick answer, just drop the bars. The answer to 29 is just t squared plus 1. Okay. 31, I'll do that one. And by the way, for some of these problems, there's really not much work to do. So remember how I said you should always show your work? There's really no work for something like this. So, just put the answer. 31, negative. This one is a negative quantity, right? So absolute value of negative radical 3 minus 4. Okay, you don't even need to know what's the square root of 3. This whole thing is definitely negative, right? It's some negative number, like negative 1.7 or whatever. Take away 4, that's negative. So I need to make it a positive. How do I make it a positive? By taking the opposite of this entire expression. Right? So how do I change a negative to a positive? I take the opposite of it. Okay? So to take the opposite of this, I just changed these signs to both positive. So radical 3 plus 4 is my answer. And you can just stop, leave it like that. Okay. Okay, we have some harder questions now. Show you these. That gets a little bit trickier. So how do you do this? Okay, so how about I'll do maybe 35 for you. Okay, blah, 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 given that x is between 3 and 4. Okay. So 35. Looks like this. Absolute value of x minus 3 plus absolute value of x minus 4. See if I read it right. X is between 3 and 4. Yeah. Well, a good way to think of it is plug in a number. Like, what's a good number between these? Well, 3.5. Plug in 3.5. Is this going to be positive or negative, the stuff inside? 3.5 minus 3. Positive, right? If I plug in 3.5 here, negative. So example, plug in 3.5. Okay. So I claim this is going to be positive, this is going to be negative. If you want to experiment with other numbers, that's also going to work, like 3.1, positive, negative. Plug in 3.9, positive, negative. So that means if this is going to be positive, I leave it alone. This one, however, is negative. If it's negative, I want the opposite of it. Negative x minus 4, like that. Since this is a negative quantity, I want the opposite of that quantity. Opposite is negative x minus 4. Okay, now I clean that up. X minus 3 minus x plus 4. I notice the x drops out. Negative 3 plus 4 is 1. So the final answer is just 1 in this particular case. All right. Okay, 39 through 47, they talk about the distance between 2 points. Okay, so let me talk about stuff like this. So taking a little time out here and talk about the distance between 2 numbers. So this is not a problem in the book, but it's just set up, as it were. Okay, how far is it from, let's say, -1 to 2? Distance between -1 and 2. How far is it from there to there? Well, it's 3 units. The way you can do that is 2 minus a -1. 2 plus 1 is 3, right? You agree with that? Distance between -1 and 2. Right. So let me generalize. Let me just pick letters. How far is it from A to B? Distance from A to B. Even though they don't give me numbers, do the same thing as I have here. It's bigger minus smaller, right? So B minus A. Do you agree with that? 2 minus a -1. So B minus A. How about if I reverse them? Like that. I still ask, what's the distance from A to B? Well, this time the bigger number is A, so it's going to be A minus B, correct? Bigger minus smaller, B minus A minus B. Now the tricky thing. Suppose you don't know which one's the larger. No picture. And you just ask distance from A to B. I don't know which is the bigger. It's either going to be B minus A or A minus B. Okay. By the way, distance is always positive. Okay. So it depends which is the larger number. Okay. So let's pretend this is 3 and this is 10. 3 and 10. Say, well, if I go 10 minus 3, I get 7. If we reverse it, you would have 3 minus 10, which is -7. So it depends on which way you subtract. Okay. If I go one way, I get 7. If I go the other way, it's -7. How could I turn the negative to a positive, though? I could say absolute value. Okay. So the distance from A to B in general, if you don't know which is the larger number, absolute value of A minus B, or you could also say the absolute value of B minus A, because it doesn't matter. Okay. So in general, if they want the distance from point A to point B, and you don't know which is the larger, which is the smaller, just take the absolute value of the difference. That means you can't go wrong. It's either going to be positive or negative. If it's positive, you're done. If it's negative, just change it to a positive by doing absolute value. Okay. So the distance from A to B is the absolute value of A minus B, or you can say the absolute value of B minus A. That'll make it a positive quantity, right? All right. With that in mind, 39. The distance between x and 1 is 1/2. Distance between x and 1, absolute value of x minus 1. So the distance between x and 1 is 1/2, 39. So So we now know the distance between two values is just the absolute value of x minus 1. And it says is 1/2, so equals 1/2. Okay, so we'll show this again. So one more time, distance between x and 1, absolute value of x minus 1, is 1/2 equals 1/2. Okay. That's how you do that. How about 43? The distance between y and -4, that's absolute value of that minus that, is less than 1. So it's going to be that minus that. Y minus a minus 4. What's y minus a minus 4? Y plus 4. Okay, so for 43, absolute value of y minus a minus 4, and then it says less than 1. Okay. Or absolute value of y plus 4 is less than 1. Okay, a little bit tricky. All right. 45, the number y is less than 3 units from the origin. Less than 3 units from the origin. That means the distance between y and 0. So in other words, I'm really taking the distance between y and the origin is 0, is less than 3. So for 45, absolute value of y minus 0 is less than 3. What's the absolute value of y minus 0? Just absolute value of y. So final answer is absolute value of y is less than 3, like that. So that's the best way to write the final answer for that one. Okay. All right. Now, a little bit harder problems for some of these. Graph on a number line and write in interval notation. All right, so I'll show you one of those, maybe a couple of those. Okay, how about I show you 49? Absolute value of x is less than 4. Absolute value of x is less than 4. Okay. Let's think of some numbers. Does 0 work? Yes. 1? Yes. 2? Yes. 3? Yes. So right now all these numbers work. Does 4 work? Absolute value of 4 is 4. 4 is less than 4 is not true. So open circle at 4. But 3.9 works, right? So it's like this. 5 does not work. 6 does not work. And any bigger number doesn't work. Let's go negative. Plug in -1. Does -1 work? Absolute value of -1 is 1. 1 is less than 4. That works. -2 works. -3. Absolute value of -3 is 3. That works. How about -4? -4 does not work. Absolute value of -4 is 4. 4 is less than 4. So -4 does not work, but -3.9 does work. Absolute value of -3.9 is 3.9. So it looks like I have this. Okay. And nothing over here works. If I plug in -5, absolute value of -5 is 5. 5 is less than 4 is false. Likewise, -6, -7, they're not going to work. So this is a set of points that works. Okay. So how do I write that in interval notation? It's parenthesis -4, 4. meaning don't count -4, don't count 4, but count everything in between. So that's how you analyze something like that. It's a little bit trickier. Now, by the same logic, though, something a little bit trickier, 55, absolute value of x minus 3 is less than or equal to 4. To use the same number 4. Now, this is the same thing as saying x lies between -4 and 4, right? So look at this and look at this. They give me something more complicated. Well, at least I still got the 4. So the thing behind my pen should work the same way, except there's a line underneath it, right? The line underneath it means both 4 and -4 would work. So I'm going to put a line underneath there, a line underneath there. So -4 less than or equal to 4. So if all it said was x, I just put an x here. But they give me something more complicated, x minus 3. I'm going to put x minus 3 here. It's a little bit weird. You have to pretend this is like one letter. Treat x minus 3 as a new variable. It is x minus 3. Okay, how do I solve for x? Now I just add 3 to everything. Plus 3, plus 3, plus 3. So that gives me what? -1 less than or equal to x less than or equal to 7. So that's my solution this time. Okay, so how do you write it in integral notation? It's bracket -1, 7, bracket, like so, because I'm including the endpoints. And to graph it, okay, -1, 1, 2, 3, 4, 5, 6, 7. Close circle because I'm including -1 and including 7, and shade everything in between. So there we go. All right, I'll do a couple more, and then I'm done with that section, and then we can break, even though it's not 12 yet, but that's okay. It probably means we're going to end early, which I'm sure you don't mind. A little bit harder is the greater than situation. So I was going to do 51 and 59. So 51, absolute value of x is greater than 1. Absolute value of x is greater than 1. Okay, does 0 work? No. Does 1 work? No. Does -1 work? What's the absolute value of -1? 1. 1 is greater than 1. False. Okay. Does 2 work? Plug in 2. Yes. 3? Yes. 4, 5, 6, 80, 100, 1,000, a million. They all work. How about here? -2. What's the absolute value of -2? 2. 2 is greater than 1. That's true. Same logic for -3. Absolute value of -3. 3. 3 is greater than 1. That works. -4 works. -1,000,000 works. -1 billion works. Okay, when you have an absolute value and a greater than situation, you're going to end up going to negative infinity and positive infinity. If you have a less than or less than or equal to, you have a region in the middle like this. You're bounded on both sides. If you have a greater than or greater than or equal to, you're going to go to negative infinity and positive infinity. Okay, how do I write this? Okay, writing in inequality notation, you have x is less than -1 or x is greater than 1. How do I write it in interval notation? Okay, if I go all the way out to the left, that's negative infinity. If I go all the way out to the right, that's positive infinity. So I'm going to write negative infinity to -1, parenthesis, again, I'm not including the endpoint. Bracket means you're including the endpoint, like this, right? Including -1, including the 7. Okay, now I'm joining it with another set. Okay? If you have intervals that need to be joined, you put a U, which stands for union. Okay? So U stands for union, and then 1 to infinity, like so. So that's the way it works. Okay, so again, if you have an absolute value greater than or greater than or equal to, you're going to end up going to the extremes, negative infinity and positive infinity. If you have a less than or less than or equal to, you're not going to go to infinity or negative infinity. You're between two numbers. It's a little bit, tougher. Okay, I'll do one more, and then I'll check the chat, and then we will break. Okay, so 59. Absolute value of x minus 5 greater than or equal to 2. Okay, let me just kind of cover this up for a moment. Pretend behind my pen is just a variable like y. It looks like this. The only difference is that there's a line underneath it. There's a line underneath here, but it's not so over here. Okay, look at the way we set this up. Set less than -1, greater than 1. So how do I do it here? Less than or equal to -2, greater than or equal to 2. So in other words, I'm going to write this. Less than or equal to -2 or greater than or equal to 2. I'm going to write something over here and over here. Okay. Look at the way I set this one up. It's a little bit tricky. Okay. Absolute value of x greater than 1. So x is less than -1 or x is greater than 1. Okay. If you think this is too troublesome, you can put an example on this on your formula sheet, on your cheat sheet for the test. Say, how do I do a problem like that? And you want to put it in your cheat sheet, you're allowed to do that. Okay. So absolute value of blah, 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 greater than or equal to 2. So less than or equal to -2, greater than or equal to 2. Now, what do I put over here and over here? X minus 5. That whole thing has to go in there. X minus 5. X minus 5. Like that. And then I add 5. Add 5. Add 5. Add 5. So this is going to be x is less than or equal to what? 3? Or x is greater than or equal to 7. Zero. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This time I'm including both endpoints. So close circle, and you shade out to negative infinity and positive infinity. Okay, and how do we write that? Parenthesis, negative infinity, 3, bracket, union, bracket, 7, infinity, like that. Okay, so that's the way that works. I'm done with that. Let me check the chat. Okay, sometimes Star might get that. So thank you, Star, if you answered some of my questions. Appreciate it. So if you ever put something in the chat while I'm lecturing, I can't look at it, but if Star wants to answer it, then Star can do that. Okay, so let me check what's in that. Okay, I think I have everything there, so I think we're all good. Okay, so yeah, it was every other odd for 1.3. And you all should have this, right? Go back to the syllabus. It's all there, and we should be good and dandy for that. Okay, so I'm done for the first half. What time is it about? 11:55. Okay, 10-minute break. Let's start up again about 12:05. Okay, so let me stop the share. Let's break until 12:05, please. Okay. All right, and I'll disappear also. Okay, folks, let's continue on. It's about 5 after. Okay, so I'll get started with 1.3. We're still recording. Go back and share the screen. All right, start 1.3. And every other odd, so that's 1, 5, 9, 13, and so on, is a review of some algebra, solving equations, and so forth. Okay, so just like yesterday, I'll lecture for a while. I'll stop. I'll give you a problem to do, and you type the answer in the chat, and then you can leave. Okay, and tomorrow will be our first quiz. Okay, so we'll see how far we get, but I'll give you a quiz at the end. In case you didn't already catch it, our class is Monday, Tuesday, Wednesday, Thursday, okay, and we don't really do anything different Thursdays than the others. So it's all going to look like one big class. I think on the schedule it says Monday, Tuesday, Wednesday is Math 225, and Thursday is Math 825. You're not going to notice anything different. It's just going to be a continuation. Okay, the only thing special, I guess, about Thursdays is that's normally when our quizzes or exams are. Okay, so Friday we have no class. I mean, I do have an office hour if you want to join my office hour. That's completely optional. You don't have to show up to that if you don't want to. Right? So we're just Monday, Tuesday, Wednesday, Thursday. All right. So 1.3, we're going to be solving equations. Okay, again, EOO stands for every other odd. Okay, so problems 1 and 5 determine whether the given value is a solution of the equation. So notice they give you an equation. All you do is plug in the proposed number. So just plug in and see if it works. Okay, so 1 and 5 are assigned. 1 looks a little bit easier than 5 just because it's a fraction. So let me do number 5 for you. Okay. And again, I've already shown you on the video all the problems, and I'll do that the whole semester. The whole semester I will just do like this and show you all the problems. So if you never want to buy the book and just go off of the video, you can. Okay, so number 5, it says m squared plus m minus 5/16. M squared plus m minus 5/16. Yes, I know you can't see it yet, but don't worry, I'll get it. Equals 0. And the proposed solution is m equals 1/4. Okay, so yes or no, does it work or does it not work? So all you do is just plug it in, and if it works, then you say yes, and if it doesn't, then you say no. Okay. So 1/4 squared plus 1/4 minus 5/16 equals 0. I'm just plugging in for m. I'll raise it up again when I have a chance so it focuses better. Right, so 1/4 squared is 1/16 plus 1/4. Well, I notice that this one is a denominator of 16 also. So I'm going to go like this, okay? Times 4 times 4, right, to get a common denominator. So 1/4 is the same as 4/16. All right, and does it work? 1 plus 4 is 5. 5 minus 5 is 0. 0/16 is 0. So the answer is yes, it definitely works. Right? That's all. So it's either going to be yes or no. Okay, solve the equation. All right, so we have 9 and 13, I guess. So how about I'll do 13 because it has a fraction. 1 minus y/3 equals 6, number 13. Okay, I don't like fractions. So let me try to get rid of the fraction. To get rid of the fraction, how about multiply both sides by 3? Right, so eliminate fractions whenever possible. So I will go like this. Multiply this by 3, multiply this by 3. So what's so good about that? That's going to cancel that 3 over there. So I don't have any more fractions. All right, so 3 times this, 3 times this, 3 times this. 3 times 1 is 3. minus, okay, so if I take 3 times y over 3, right? 3's cancel out, so I just have y. Equals 6 times 3 is 18. And then look at what I got. Much better, right? This one has a fraction. This one no longer has a fraction, so no big deal. Okay, so subtract 3. Minus 3. Negative y equals 15. That's negative y, right? So you recall, if you have negative y equals 15, what does that make y? Negative 15. What is the operation? You can say multiply both sides by negative 1. Or you could say divide both sides by negative 1. So y is equal to negative 15. Okay. Okay. Harder problems. Oh, these look real bad, right? So to solve these, get rid of those nasty fractions, right? Eliminate the fractions whenever possible. Okay, so let's see, 17 and 21 are both assigned. How about I'll do 21 for you because it looks a little harder. Okay, and you do 17. So 21, please. 21, 5 over x minus 4 minus 3 over 2x squared minus 5x minus 12 equals 1 over 2x plus 3. Double check that I wrote it correctly. Yeah, looks good. All right. This is sort of like a trade secret. Okay, I got to factor this. Okay. After a while, you kind of know the way these problems work. You say, I wonder how these factors. Let's just look at these two. Yeah, I mean, even before I looked at this problem from experience, you kind of know, all right, it's going to be that times that. So 5 over x minus 4 minus 3 over 2x plus 3 x minus 4 equals 1 over 2x plus 3. Okay, and let me raise it up for focusing. Let's double check by foiling this back out. 2x times x is 2x squared. 2x times a negative 4 is a negative 8x. Plus 3x is indeed negative 5x, and there's minus 12. So it works. Okay, how do I eliminate the fractions? Well, just like over here, but it's a little bit harder. Multiply by the common denominator, which is 2x plus 3, x minus 4. Okay. So on both sides, I will go like this. It's kind of hard to cram this in, so I'm going to write sideways. 2x plus 3, x minus 4. I sort of painted myself into a corner. I don't have enough space here. 2x plus 3, x minus 4. 2x plus 3, x minus 4. Okay. Fortunately, it's not that hard to do this, even though it's kind of sideways here. Take these two times that and times that. Now, there's something else about this problem. There are variables in the denominator. Remember that we're never allowed to divide by what number in mathematics? We're never allowed to divide by 0. So for instance, pretend this x is a 4. 4 minus 4 is 0. Can't do it. Okay? So whatever I get for my answer, I got to plug in to double check that I'm not dividing by 0. Okay? So check that we're not dividing by 0 when I get my solution. Okay? You always have to do that when you have a variable in the denominator. Now you might say, well, how come you didn't do that over here? Well, over here there was no variable in the denominator. There's only a number, constant. Here, because there's a variable denominator, x cannot be 4. X can also not be negative 3 over 2. If you solve this, set that equal to 0, you get negative 3 over 2. Okay. But we don't have to worry about that until we see what the answer is. So I'll take my answer, plug back in, and see if I get a 0 on the bottom. Okay, so if I take these two guys times this fraction, x minus 4 cancels out, right? It's 2x plus 3, x minus 4 times this. X minus 4 cancels. I will have 5 times this one, 2x plus 3. Minus. If I take both of these times this, all of this cancels out. I only have 3 left. Then over here, 2x plus 3 cancels out. I have 1 times x minus 4. X minus 4. Okay, it looks a lot better. I'm still far from done, but this looks a lot better than what I started off with. No more fractions. Okay, so let's clean that up. Distribute 10x plus 15 minus 3 equals x minus 4. 5 times 2x, 5 times 3. Let's see, 15 minus 3 is 12. 10x plus 12 equals x minus 4. Subtract x, right? Subtract x, subtract x. When you have x's on both sides, get them on the same side. 9x plus 12 equals negative 4. Okay, so now get rid of the 12, get rid of the 9. How do you get rid of 12? Subtract 12. Minus 12, divide by 9. X is negative 16 over 9. So that's my solution. And a quick double check, if I plug back in, I'm not going to divide by 0, right? The problem number here was 4. I can't plug in 4. This was negative 3 over 2, something like that. Certainly not that. So we're good. We just leave this solution. So that's my answer. Okay. Okay, hopefully you find all of this is review. You should mostly be reviewing here. Okay. Solve by factoring. Whoops. Solve by factoring. Okay, so we have to factor. Okay, so I see 25, 29, and 33 are assigned. So how about I'll do 29 for you. Oh, there we go. Focus is a little bit better. 29, x squared plus 3x minus 40. Solve by factoring. That means you go like this. Remember doing this in algebra? X squared, x times x. You have a minus sign here. The minus sign here means that these two signs are opposite. They're opposite of each other. One's a plus, one's a minus. That leads to a difference of 3. Okay, so think to yourself, what two numbers have a product of 40? When you multiply them, you get 40. The difference is 3. That'd be 8 and 5, right? They're 3 apart. When you multiply them, you get 40. 8, 5. Okay, which one gets the plus and which one gets the minus? Well, there's a plus here. That means plus should go with a bigger number. Plus, minus, like so. Okay. If this had been a minus, then this would be a minus, and that would be a plus. Okay, and you might recall that means either this is 0 or this is 0. What number would I plug in to force this to be 0? Negative 8. What number would I plug in to make this thing 0? 5. So there's my two solutions, negative 8 and positive 5. Okay. All right. 33 looks pretty bad, actually. Yeah, I'll set you up for that one. Maybe you've never seen something like that before. X squared plus 2 radical 5x plus 5 equals 0. That looks real weird. X squared plus Okay, so on the one hand, you might say that's kind of hard, but on the other hand, it's actually easier than you might think. X squared is x times x. Plus, 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 plus. Now, this times this has to be 5. So if you're thinking nice numbers, the only nice numbers I can think of are 1 and 5, right? But you know that's not going to work. I got to end it with 2 radical 5. So this plus this is 2 radical 5. This times this is 5. Well, we stop and think about it. What adds up to 2 radical 5? Well, how about a square root of 5 and another square root of 5? And when you multiply square root of 5 times square root of 5, you get 5. So it's actually this, strangely enough. You can check it with FOIL, multiply it back out. X squared, okay, radical 5x, and another radical 5x. That's 2 radical 5x. And then plus radical 5 times radical 5 is 5. Okay, so that was kind of weird. And by the way, I can now write that as a square, like that. Okay, so that means I just have to set that equal to 0. X plus root 5 equals 0. Just subtract radical 5. So the answer is x equals negative radical 5. Okay, so that's all. It's just kind of weird. All right, I won't go too much longer. By the way, I wasn't intending on finishing all of this. I am a little bit ahead now. In fact, I was going to, on the schedule, only go up to 1.3 by tomorrow. I've already started 1.3. Okay, so I don't have to finish 1.3, otherwise I'll be a whole day ahead. Okay, so I'll probably stop after a certain while and do 1.3 and sneak in some of 1.4 tomorrow before I give you the quiz. So I'm a little bit ahead. That's okay. Okay, 37 and 41, quadratic formula. Okay, so give it in radical form and a calculated approximation to 2 decimal places. All right, quadratic formula. Remember the quadratic formula? Quadratic formula. Now, your previous teachers may have made you memorize it. Okay, since we're under COVID, they told us to make things easier on the students. So if you forget the quadratic formula, you can put it on your cheat sheet. Okay, so we start off in standard form. If you have an equation in standard form, ax squared plus bx plus c equals 0. X is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Now, on the one hand, you can put down anything you want on your formula sheet. But remember, on the other hand, I put in my syllabus, you only get one front and back 8.5 by 11 sheet of paper. Okay, so if you put down the quadratic formula, maybe you don't have enough room for other stuff. So then maybe some of you already have the quadratic formula in your head. Say, oh yeah, I got this down pat. I got it memorized, so I'm good with it. And then I'll have to put that on my cheat sheet. Okay, so it's up to you. You can put it or not. Okay, so how about I do 41 for you? That looks like a pretty bad one. (24x squared plus 23x equals negative 5. Okay. So it says, give the exact answer in radical form and a calculator approximation to 2 decimal places. Okay, I'm gonna have to get a calculator ready for this. I'll get my calculator handy here. All right, is this in standard form? Does that look like that? No, it doesn't. This is supposed to be 0. How do I make it 0? Add 5. There, right? Now it's in standard form. A, B, and C. So I take the A, 24, B is 23, C is 5, throw it into this thing. Okay, I reached the bottom of my paper. I got to go back up. Good, you get the idea. Okay, so I'm going to throw into the formula. A is 24, B is 23, C is 5. Okay, so here we go. X is equal to, so negative B is negative 23, right? Plus or minus the square root of B squared. So use your calculator for 23 squared. 23 squared, 529. Minus 4AC. 4 times 24 times 5. All over 2 times A, 2 times 24. Okay, so this is a mess. So what is this? 4 times 24 times 5, 480. $529 minus 480 is 49. Oh, comes out nice. Over 48. Square root of 49, 7. Okay, that's not so bad. Okay, so I'll do the negative. Negative 23 minus 7 is negative 30 over 48. And that can be reduced. Let's see, what can I take out? I can take out a 6, right? If I take out a 6, negative 5/8, which as a decimal is negative 0.625. And if I do the positive, negative 23 plus 7 is negative 16 over 48, which is negative 1/3. That's negative 0.3 repeating. All right, so that's quadratic formula, as you know. All right, I think I'll just do one more. I'll check the chat, then give you a problem, and then we're done, okay? So it's only about 12:30-ish. Solve by any method, solve by the method of your choice. So do whatever you want, I guess. So let's see, 41, 45, x squared minus radical 5 equals 0. That's the only one that's like that, okay. X squared minus radical 5 equals 0. All right, move that over. X squared equals radical 5. If you temporarily ignore the fact that this is a bad number, you would do the square root property, right? Square root property means square root, plus or minus. Don't forget the plus or minus. Okay, so quick timeout. This is a little sidebar. Suppose you had x squared equals 9. By the square root property, you might say, oh yeah, do the square root, and my answer is 3. No, negative 3 also works. So you have to go plus or minus. X is plus or minus 3. Is that right? See, 3 squared is 9, but negative 3 squared is also 9. So that's why you have to do plus or minus. So what am I taking the plus or minus of? I want the square root of 5. Okay, and that's really weird. So how do I do this? Square root of the square root of 5. Okay. Well, you might recall from your algebra, when you have a square root, I can write the square root of 5 like this. 5 to the 1/2. Okay. A fractional exponent means this is the power, this is the root. Okay. When I write the square root of 5, you pretend there's a 1 here, and you pretend there's a 2 here. Okay. 5 is like 5 to the 1. Square root means there's an understood 2 here. So it's 5 to the 1/2 power. But now I'm taking the square root of this. So whatever is behind my finger is also raised to the 1/2 power, right? That square root matches that. So what do I put in here? 5 to the 1/2. So I'm taking 5 to the 1/2 to the 1/2. Sorry, I forgot the plus or minus. Square root of a square root means 1/2 power of a 1/2 power. And do you remember what happens when I have something like this? If you have a power, another power, multiply them. So how much is 1/2 times 1/2? 1/4. Okay, and now write that back as a radical. The power is 1, so it does an understood 1 here, but now you put a 4 here. Okay, so in other words, you basically have plus or minus the 4th root of 5 is my answer. Okay, so plus or minus the 4th root of 5 is what I have. All right, I'm not done with this section. I was going to stop there, but that's as much as I was going to do today. Okay, I'll give you something to do also. So I'm a little bit ahead. I wasn't supposed to do 1.3 until tomorrow. I'm done with more than half of 1.3. So I'll do 1.3 and I'll probably sneak in some of 1.4 tomorrow before I give you the quiz for tomorrow. Okay, I know some of you had something in the chat, so let me double check the chat, please. Yes, there, yes. Is 1.3 going to be on the quiz? I'm not sure, I haven't decided, okay? The quiz is really in quotes. It's really more like an in-class assignment. In fact, everywhere it says quiz on the, this, maybe to take off the stigma of the word quiz, just think of it as an in-class assignment. I mean, you get to talk about it, you get to use your book, you get to use your notes, you get to discuss it, right? So I just wrote the word quiz because it's the shortest way to write it, but it really should be in-class assignment. But, it's too much writing to write in-class assignment 1, in-class assignment 2, in-class assignment 3. So I just call it a quiz, but it's not really much of a quiz. So, 1.3 might be on it, okay? You turn in the homework whenever we have an exam, correct? So you don't turn in any homework until February 4th. And then what do you turn in? Everything from here to 2.4. In other words, everything from here to here. Okay. Any other questions, please? All right, so right now, okay, and this is what I'm going to do. When you type in your answer to me, please give a private chat, because if you make it public, then somebody can just look, oh, the answer is 27. I'll just type in 27 what somebody else did, right? Okay, so please send me the answer as a private chat so somebody else can't just, look at the chat and say, oh, I got the answer and go from there. Okay, otherwise it's just like yesterday. Okay, so when you type in your answer, that's your pass to leave. Okay, so let's go back and do problem number 9. Okay, right now. Okay, so work it out. You don't have to show me your work for this one because it's too hard to type it. Now, so I'm kind of contradicting myself. I say always show me your work for quizzes, for homework, for exams, but not for this stuff. It's too much to type all that in the chat. So do problem 9 right now. Just give me the answer. M is equal to whatever. You don't even have to write M equals. Okay, put it in the chat and you may leave. Okay, so number 9, if you need to take a picture on your cell phone, maybe you can go ahead and do that, please. Let me get this. Yeah, I want to make this disappear so I can turn off the camera. So if you don't have the text, do problem 9, take a picture on your cell phone, or maybe write the problem down. Solve 1 minus parentheses 2m plus 5 equals negative 3m. Okay, so I'll hold this for maybe 15, 20 seconds, and then I'm going to make it disappear. So either take a picture on your cell phone or write it down, please. Question 9, 1 minus parentheses 2m plus 5 equals negative 3m. If you're not sure how to do something, you can ask me or ask Star. Okay, and if you put the answer in the chat and you have no further questions, you may leave, and I'll see you tomorrow. Okay, I'll give you just a few more seconds. Work out question 9. Normally, yes, I want you to show all your work. For this one, just put the answer. You don't even have to write M equals, although you can if you want to. Please send a private chat. If you make it public, then somebody else can just peek at what you did and type the answer. So do me a favor, write it as a private chat, and then you may leave. Okay, I'm going to make this disappear. Okay, and I'll stop the share. And if you're done, you can just send it, and I'll see you tomorrow. Okay, I'm going to stop recording also. There's nothing else to record.